Hello and welcome. In this video, we are going to discuss about rotational mechanics problem. Consider a cylinder of mass m equals to 1 kg and radius 1 meter lying on a rough horizontal plane. It has a plank lying on its top as shown in the figure. A force of 55 Newton is applied on the plank such that the plank moves and causes the cylinder to roll. The plank always remains horizontal and there is no slipping at any point. And we have to calculate these three following questions. You can pause the video and try the question on your own once and come back to the video when you're done. So let's begin with the solution. To solve the first part, we split the image into two parts separately and we draw the free body diagrams called the FBD. We have the two components of the force, that is F sin theta and F cos theta. We have the friction F1 acting towards the left for the plank. We have mg acting downwards for the plank and the normal reaction N1 acting for the plank. And finally we have the resultant acceleration A acting on the plank. Now we have mg acting on the cylinder's center of mass and we have the normal reactions on the cylinder as well, at the top N1, at the bottom N2. And we have the frictional forces as F1 and F2 respectively acting at the top and the bottom. And we have the linear acceleration A and the angular acceleration as alpha. Now we are going to use these forces to write different equations. Let's see. The first one is for the plank, which is given by F cos theta minus F1 equals to MA, the resultant force. Then we have F sin theta plus N1 equals to mg. Now let's come to the cylinder. We have F1 plus F2 equals to ma, which is the linear forces. And then we have the torque equation, F1 dot r minus F2 dot r equals to I alpha. And finally we have A equals to R alpha, which is the pure rolling condition. And now we are going to relate this capital A of the sphere to the small a of the plank. Let's see how to do it. At this particular instant, we can assume that the sphere is rotating with respect to the bottommost point as shown here. Then this A can be written as R alpha, and therefore the topmost point can be written as twice of R alpha because it is at a distance of 2r from the bottom, and therefore the linear acceleration is given by twice of capital A. Now since this point does not slip with the plank, therefore we have the linear acceleration of the plank small a to be equal to twice of capital A, and this we mark as the sixth equation. Okay, so finally we have all the sets of equations, and now let's go into solving them. Using equation 4 and plugging in r equals to 1 meter and I equals to half mr square, which in this case is half m because we have r equals to 1, we have F1 minus F2 is equal to half m alpha, which can be written as half ma. Now adding equation 3 to the above equation, we get 2F1 equals to 1.5 ma, which gives us F1 equals to 3 by 4 of ma. Plugging this result in equation 1, we get F cos theta minus 3 by 4 ma equals to the small ma. And replacing small a with capital A using equation 6, we get F cos theta minus 3 by 4 ma, which is equal to twice of small m times capital A. And if we rearrange, we'll finally get capital A is equal to F cos theta by 8m plus 3m, which is the linear acceleration of the cylinder. Hence, I plug in the values and get my final answer as 10 meter per second square, which is the option B. Okay, let's do the next part. For the next part, we have find the value of the frictional force at point P. So we see that friction at this point P is F1, and this I can just plug in the values and get 3 by 4 times 1 times 10 equals to 7.5 newtons, which is my option A. Okay, so let's go to the next part. Question number 3. Find the value of frictional force at the point Q. Let's see how to do it. So friction at point Q is F2, and this is simply given by MA minus F1. We already know the values, we can just plug it in and get 2.5 newtons, which is my option C. And with this, we get the answers to all the three parts, and this is how we can solve a question on rotational mechanics easily. If you like the content, please do like and subscribe to our channel for more content on JEE. Thank you.